This is Unit 8, Section 8.4. We're going to be factoring trinomials, and we'll spend a couple of days on this as we start to kind of get the hang of this. So it's going to be putting together what we've done with our previous days of GCF and factor by grouping. And so this is something that we're going to look at as we continue the rest of this time. All right, so just like before, we're going to warm up by multiplying and distributing out. So again, this is how we can always check our answers, by distributing x times x, x times -5, 1 times x. I guess I don't need to write the 1 times -5 here. So again, I start with 4 terms. And again, if we looked back at this, we could factor going this direction, but we're simplifying. So we want to combine our like terms here in the middle. So -5 plus 1 is -4, and then -5 here. Now I have a trinomial. Our goal is going backwards from this step back to this step. We already know what to do when we have 4 terms. This is where we did our factor by grouping previously to get back to this. Now we're going to have to take our middle term, and again, as we're going backwards, we're going to have to take this -4x and split it. So this is going to be the new part. Then we're going to go back to our 4, and that's where we can go back to our grouping to get our 2 binomials being multiplied here. So again, we're looking for patterns here. 2x times x, there's our 2x squared. 2x times 1, there's our plus 2x. 3 times x, there's 3x. 3 times 1, there's 3. Combine our middle 2 common terms. I bring down my 2x squared. 2 plus 3 is 5x. Bring down the plus 3. And so again, our goal today is going to be going backwards. We've practiced going this direction. Now we're going to practice going the other direction. It's just like in elementary school where you start out multiplying and then you learn dividing. When we did our Unit 5, that was multiplying. Now we're doing our factoring. This is the dividing, going back to the multiplication. So once we started with 3 terms, notice that again, we were okay when we had 4 terms. This is going to be our new part. How do we go from 3 to 4? And so it turns out there's a way that we can do this consistently every single time. And so one of the things that we're going to look at is what I call these kind of X puzzles. And so it says, in each diagram below, write the 2 numbers on the sides of the X that are multiplied to get the top number. So multiply to 12, multiply to 18, multiply to a -36. But added together, get the bottom number. So plus here, plus here, plus here. So I'm trying to come up with 2 numbers that multiply to 12 but add to 7. Multiply to 12 and add to 7. So if I think of 12, I can say 1 and 12. That would multiply to 12. But if I added those together, I would get 13, not 7. 2 and 6 multiply to 12, but if I add them together, that gets 8, so it doesn't work. 3 and 4 multiplies to 12, and if I add those together, that's where I would get 7. 3 and 4. This is going to be the part that allows us to split this middle term into 2 terms. These 2 numbers are going to be important as we're moving from here to here. Notice that we found 2 numbers here. All right. So what 2 numbers multiply to 18 but add to -9? 1 and 18. Okay, doesn't work. 2 and 9. Doesn't work. 3 and 6. So again, in my head, I'm just adding those together and looking for the one that makes -9. All right, so this would add together to make a +9. So how do I get it so that I have a -9, but a positive multiplication? So some of these are, again, they're puzzles where we're trying to figure out what multiplies to a positive but adds to a negative. The only way I can get a positive number is by multiplying a positive and a positive, or a negative and a negative. Notice that if this answer is negative, I need two negatives here. So if I change my signs, -3 plus a -6, that would get me my -9. Now these are the two numbers that would multiply to a positive 18, checks off here, and add to a -9 down here. All right, on the next one, multiplies to a -36. Okay, so we have 1 and 36. Okay, but we want them to add to 0. Ooh, what kind of numbers add to 0? This would be 37. 2 and 18, that's 20. 3 and 12 is 15. 4 and 9. Okay, so 4 and 9 would be 13. 5 doesn't go in, so 6 and 6 is 12. And then once I get back to 6, well, then I'm back to the numbers over here. All right, so something didn't work here. We didn't multiply to 36, but added to 0. We never got 0 on this side. One of the things I didn't look at was the negative. If I want a negative, I need a positive number and a negative number. So let's look again. If I have 1 and 36, how far apart are there? They're 37 together, or I could make a positive 35 or a negative 35, depending on which one was positive or negative. But again, I'm looking for 0, so it's still out. 2 minus 18 is -16. 18 minus 2 is 16. So again, I could make 16 or -16, but it doesn't work. I'm looking for 0. 3 minus 12 could be -9. 12 minus 3 could be +9. So I'm looking for 9 and -9. Doesn't work here. 9 minus 4 is 5 or -5. Doesn't work. But here's what works. I get 0, or the other way, I get 0. This one is what I'm looking for. I want a +6 and a -6. Multiplies to the top, adds to the bottom. When we are doing this, be careful on the signs. It's really going to change and make a difference here. If you put 6 and 6, absolutely multiplies to a +36. We have to be careful on the signs. These are going to be the more simple ones where it's positive and positive. We don't have to worry about the signs, but there's some patterns here that we can look. If the top number that we're multiplying to is negative, that means I have to have one positive, one negative. If it's positive here but negative here, both are negative. Some patterns going on here, thinking through it. So when we look to the steps to factoring a trinomial, okay, we're going to eventually get to factor by grouping. So everything that we've done here is what we did the day before when we had factor by grouping. So how do we get to that? So here are the steps to factor a trinomial that is ax squared plus bx plus c. It says find two integers that multiply to, and then we're going to say c here. And I'm actually going to say a times c, sorry. A times c and add to b. So we're going to take the coefficients a and c and we want them to add to b. And so when we look at this here, we're going to do a times c here and b here. So when we look at our example, and I think I'll put that here, a times c here, b down here. So our example, we have a is 1, so I'm bringing the 1 out here. B is 5, and c is 4. So 1 times 4, this is where I get 4 here, and 5 down here. We want them to multiply to 4 and add to 5. So can we find and complete the puzzle? This is the part that's new, where we're trying to find those two numbers to split this middle term. All right, so what multiplies to 4 but adds to 5? So when we think of our factors of 4, we have 1 and 4 and 2 times 2. The only one that multiplies to 4 and adds to 5 is 1 and 4. All right, step 2. Once we found that, it says split the middle term into the integers that you found on step 1, creating our 4 terms. So I'm going to take this 5x, x squared plus 5x plus 4, and I'm going to split the middle term. And I'm going to write this as x squared coming down, and then I'm going to say this is going to be 1x plus 4x. Notice that those two, I'm not changing the value or the quantity, but I'm changing this into 2 terms. I could have said 2 and 3. I could have said, negative 11 and positive 6. Actually, the other way around, positive 11, negative 6. But I want it specifically to multiply to 4. That way I have my grouping ready to go. So I have specifically picked these 2 numbers, the 1 here and the 4 here. This is the new part here. Coming up with those 2 numbers helps us now go back into our 4 terms. Now it is factor by grouping. We can group these 2 terms. So now I'd have x plus 1, group the second 2 terms, bringing down our plus. They have 4 in common, x plus 1. Now I've grouped them and factored out their GCF. Notice that now my 2 terms have an x plus 1 in common. Okay, and if I take out the x plus 1, x plus 4 is left over. So we can still always check by distributing. X times x gets us back to x squared. X times 4 gets us back to 4x. 1 times x gets us x, and 1 times 4 gets us 4. These 2 terms combine back to the 5x that we started with. This is a process, but it's a process that is a pattern that no matter what, every step goes back to the previous step. So I could have checked here. Does 1x plus 4x equal 5x? I'm good. Okay. Does x times x take me back to x squared, and x times 1 takes me back to 1x? 4 times x is 4x. 4 times 1 is 4. I'm good on this step. X plus 1 is in the first term. X plus 1 is in the second term. X plus 4 is what's left over, and this was me multiplying it back out to go up to all the way to the top. It always multiplies to the previous steps. So there should not be any steps or procedure here that you can't check and stop at any point and go, okay, where did I leave off? Does it work backwards? So let's check and factor each trinomial. All right, so again, trinomial, 1, 2, 3 terms. I draw my x out front, and I'm going to do 1 times 20. So 1 times 20 is 20, and then 9 on the bottom. So I need 2 numbers that multiply to 20 and add to 9. Okay, so the factors of 20 are 1 and 20, 2 and 10, 3 doesn't go into it, 4 and 5. And as soon as I see 4 and 5, I see that those 2 will add to 9. And remember, we looked on our calculator on how to generate this list if we're struggling. All right, so I'm going to split the middle term. So I bring down my 8x, or my x squared, and then I have plus 4x plus 5x, and bring down the plus 20. So I've split 9x. These 2 go back into the 9x here. Now I'm ready to group. Okay. X squared and 4x have an x in common. X plus 4 left over. Plus 5x and 20. I can take a 5 out of both of those. Which, again, I should have that matching binomial. X plus 4 coming out. And if I take out the x plus 4, my leftover binomial is x plus 5. The new part here is coming up with these 2 numbers to split And then from there, we have our factor by grouping. Here's my final answer, factored out completely. On number 2, okay, I have a 1 here times 24. So 1 times 24 is 24. And 10 in the middle here. So my factors of 24 that add to 10. So I can say 1 and 24, but that's going to be 25. 2 and 12, that's 14. 3 and 8 gets me 11. 4 and 6, that's what I'm looking for here. I was almost tempted with the 2 and 12, but one of them would have had to be subtracting, and since this is positive, they have to have the same signs. So my 10x I'm going to rewrite as 4x plus 6x. I'm going to make those two add to go back to my middle term. That's why we call this splitting the middle term, factoring the trinomial. I bring down my x squared and my plus 24 at the end, and then I'm ready to group. First two have x in common with x plus 4. Second two, almost lost my plus sign. 6x and 24 have a 6 in common with that same x plus 4 left over. The x plus 4 is the common binomial here. And x plus 6 is what's left over after taking out that binomial. Every time that I check, I can go back. 4x plus 6x goes back to the 10x. X times x is x squared. X times 4 is 4x. 6 times x is 6x. 6 times 4 is 24. X times x is x squared. X times 6 is our 6x. 4 times x is our 4x. 4 times 6 is 24. We always can check our work going backwards. All right, on number 3. Oops, sorry. What happened? All right, number 3. Okay, so I have a 1 out front. 1 times negative 18 is negative 18 and adds to 3. And so when we're looking at this, now I want factors of negative 18, which tells me if I multiply to a negative, I need a positive and a negative here. So 1 and 18. Okay, so now I'm thinking adding and subtracting. So 1 minus 18 doesn't get me 3. 18 minus 1 doesn't get me 3. 2 times 9 gets me the 18, but think subtraction. 2 minus 9, negative 7. 9 minus 2, 7. So what about 3 and 6? Okay, that gets me my 18. I need subtraction, but I need a positive 3. So I'm going to have a negative 3, positive 6 here. The bigger number has to be positive to keep this positive. So that's going to be my answer here. Once I have my pieces here, I can split that middle term. Positive 6x minus 3x. This is what I specifically picked to go back to 3x. Bringing down my minus 18 and my x squared. Now I have 4 terms that I'm ready to group. X squared and 6x have x in common. I have a minus coming down, which changes this to plus here. 3x and minus 18 have a 3 in common. X plus 6 being my matching binomial there. X plus 6 taken out of the first and the second, leaving me with x minus 3. This would be my completely factored binomial times binomial to get me back to my trinomial. On number 4, x squared plus x minus 6. Okay, so I have my 1 times negative 6 is negative 6. That adds to a 1 here. All right, so my factors of 6 are 1 and 6 and 2 and 3. If I have a negative here, I want to think subtraction. That makes 5. Here I can make a 1. So positive, negative. I could have a positive 2. Ooh, I need a positive 3 and negative 2 to make it a positive 1. The bigger number needs to be positive. So I'm going to rewrite 1x as 3x minus 2x. Bring down my x squared, bring down my minus 6. And now I'm ready to go back to grouping. X squared and 3x have an x in common. I have a minus that comes down, which changes my second sign. 2x and 6 have a 2 in common. X plus 3 coming down. And now my two terms, I have that common binomial of x plus 3. Once I take that out, I have x minus 2 left over. So again, as we're going through this, I want us to see these numbers. And so we're coming up with our two numbers to split that middle term. Our two numbers to split the middle term, and then everything else here is what we did before with factor by grouping. All right, so let's multiply again. 1 times negative 3 is negative 3. Add to a negative 2. All right, so my factors of 3, well, it's prime. It only is 1 and 3. So if I need a positive and a negative to make our negative here, how do I add to a negative? Now the bigger number needs to be negative to keep that sign. So I'm going to split the negative 2 and write it as positive 1x minus 3x. Always goes back to what we started with. Bring down the minus 3, bring down the x squared, and now we're ready to group. X squared and 1x have x in common, leaving me with x plus 1. I have a minus coming out, so that changes my sign to plus here. 3x and minus 3 have a 3 in common, and an x plus 1 should match. All right, so then once we have that, we can factor out our x plus 1 from each of those terms, leaving us with x minus 3. Here's my factored solution. I can always check it back. X times x gets me x squared. X times negative 3 is negative 3x. 1 times x, there's 1x. 1 times negative 3 takes me back here. Combining the middle gets me back to the original trinomial. It's very repetitive, but we have to keep practicing, making sure that we see each of those parts. Excuse me. Twins. All right, sorry. All right, so on number 6, we're multiplying. 1 times negative 63 is negative 63. And we want numbers that multiply to negative 63 but add to negative 2. All right, so 63, 1 and 63. Again, these are the ones that are tricky because I have to have one positive and one negative to make a negative here. So think subtraction. I can make a negative 62 or a positive 62. Not going to work. 3 and 21 is the next one that I see on my list. Okay, I can make a negative 18 or a positive 18. I need them to be closer together. 4, 5, 6, 7 times 9. This is where I can get my negative 2. I need the bigger number to keep the negative there, and so I have my two numbers. I can split negative 2x into 7x minus 9x. Bring down my negative 63, bring down my x squared, and my 4 terms now are ready for grouping. X squared and 7x, I can take out an x, leaving me with x plus 7. Minus changes my minus here to plus, and then group my second two. 9 and 63 have 9 in common. X plus 7 should match there. So when I bring it down, I have x plus 7 and x minus 9. Once I take out that x plus 7. Here will be my final factored form. Check your work by distributing x times x times negative 9, 7 times x, 7 times negative 9 there. And we check, that checks out to the middle trinomial piece there. Always worth it to check your work. It's quick, and you should be able to do most of it either quickly on the calculator or in your head. All right, on number 7. All right, we have 1 times 24. So 1 times 24, we get 24. And then we want it to add to a negative 11. All right, so now we have a positive here and a negative here. This is our first one that both of these are going to be negative. So when I think of 24, I want two numbers that add to make that negative 11. 1 and 24, if they were both negative, would be negative 25. 2 and 12, both negative, would be negative 14. 3 and 8, if they were both negative, bingo, there's what we're looking for, negative 3 and negative 8. So we're going to rewrite negative 11 as negative 3x minus 8x. Bring down our 24, bring down our x squared. And now we're ready to group. X squared and 3x have an x in common. X minus 3 comes out. X times x is x squared. X times negative 3, negative 3x. Minus changes our sign to minus here. 8x and 24 have 8 in common. X minus 3 left over. Again, should match my common binomial, so I can take out that x minus 3. Leaving me with x minus 8 as my leftover binomial. Again, we can still always multiply back to what we started with. On number 8, we have 1 times 72 and negative 17 here. Okay, so 72, I'm looking at my list. I have 1 and 72. Positive here, negative here means I have two negatives. So I have to make sure that they combine to make a negative 17. Those are too far apart. 2 and 36, I can make 38. 72, what was on my list? 3 and, okay, I didn't actually have my list pulled up. Let me see. 24. Okay, still not working for me. 4 and 18, I'm getting closer. But still that makes 22. 72 and 6 is my next one. Or I'm sorry, 6 and 12 is my next one, but that's 18. And the last one, then I have 8 and 9 are the last two. So those are going to be the two that make negative 17. Woohoo! Let's do negative 8 and negative 9 here. So I'm going to rewrite negative 17 as negative 8x minus 9x. Plus 72 comes down, x squared comes down, and last step is to start grouping. X minus 8, minus, changes the sign to minus here. 9 and 72 we just saw has 8 that comes out of it. Once I look at my two terms, I can take out that x minus 8 that matches, leaving me with x minus 9. I can always distribute to recheck that. All right, so our last two problems here are putting it together with a GCF. When we are looking at this unit, it always goes back to our day one, factoring the GCF. A lot of this is factor by grouping. This is kind of our special pattern that we have. We're going to get to our mixed review here. So these are our main ways of factoring. GCF, trinomials, grouping, difference of squares are our main ways that we're going to be grouping. Or I'm sorry, factoring, with grouping being one of them. When we get to trinomials like this, we just did 8 that didn't have something in common. What if we first looked for and factored out a GCF, then factor the trinomial that remains? On these two, our first step should be to look for a GCF. 4x squared, 12x, and 8. On all three terms, is there anything that I can take out? So when I look at my three terms, I can take a 4 out of each one of those. So if I have a 4 taken out, I have 4x squared, divide the 12, I have 3x, divide the 8, I have 2. And what that is going to leave us here is with a trinomial. On day one, this is where we stopped because everything that I had given us was a prime remainder here. But now we want to be thinking, I have a trinomial. Are there factors of 2, 1 times 2, that add to 3? Well, the only factors of 2 are 1 and 2, and they do add up to 3, so I can split this middle term into 1x and 2x. Bringing down the 2, bringing down the x squared. This 4 just keeps coming along down and down until we get our final answers down here. So just like before, we have 4 as part of our answer, but it's not part of this next process here of the factoring by grouping. Now when I pull out x on these, okay, and then I have my plus, and 2x and 2 have a 2 in common. Notice that the 4 is already ready to go down here. It's part of my answer because that's how I get back to the original, but it's not part of my grouping here. I do, you guys, I missed one. 2 times 2 would be 4. This should be a 1. All right. Otherwise, as soon as I went to underline, I was like, oh no, they don't match. They do match. I have an x plus 1, and then what's left over is x plus 2. All right, so this is the newer part here. The GCF is not new, but factoring a trinomial with a GCF is new. So let's look at this again. If I have 3x squared plus 30x plus 63, first look for and factor out the GCF. So what goes into all 3 of these is 3, leaving me with x squared plus 10x, and factor that out, we get 21. So again, the 3 comes down. It's part of our final answer that we always are going to have look like this, but it's not part of my next steps where I'm looking for what multiplies to 21 but adds to 10. So I see 3 and 7 there, so I'm going to split 10x into 3x plus 7x, bring down my 21, bring down my x squared, and now I'm ready to group. Notice that I've already taken care of this 3. People forget to bring down their GCF. It's almost like they think, oh, I took it out, it's gone. No, this would not multiply back to the original without the 3. But it's not part of my grouping. I don't need it here. Plus 7 and 21 have a 7 in common. Common binomial, x plus 3. There's my 3. And if I take out the x plus 3, I'm left with x plus 7. So when I multiply back out, x times x gets me x squared. Times 3 gets me the 3x squared. That's where we would keep going, okay? X times 7 is 7x. 3 times x is the 3x, okay? Here, 3 plus 7 is 10. 10 times 3, there's my 30. So again, as I'm working my way back, I always have to remember that this 3 was part of my original answer. So it needs to be part here as well. All right, this is a skill that we're going to keep practicing, but notice that it really builds off of a GCF. If we can find a GCF and factor numbers with variables, we're on the right track. Let me know if you have any questions.